Your bird vanishes every night, and you have no idea where it goes. You've lived with birds, or near them, your entire life. You've watched them eat, sing, argue over perches, and pace the rim of their water dish like something is always slightly wrong. But every single night, the moment the light drops, they disappear from your awareness entirely. For 8 hours, every night, for years. Researchers at the Cornell Lab of Ornithology estimate that wild passerine birds spend roughly 40% of their lives in a state you have never once witnessed. Not fully, not honestly. 40%, that number is not metaphorical. It refers to real biological time, hours per night, multiplied by years, spent in a condition so different from waking bird behavior that some ornithologists now describe nocturnal avian states as a separate physiological mode altogether. So what is actually happening? If you find yourself genuinely unsettled by that question, consider subscribing before you go any further. What this channel uncovers about birds, about the hidden architecture of their biology and awareness, is the kind of knowledge that permanently changes how you look at the animals already living in your home or your backyard. This channel exists to find the things that science has confirmed but popular culture has never bothered to tell you. Every video here is built from peer-reviewed research, field data, and direct consultation with the published literature, not folklore, not guesswork. The emotional register is awe. The standard is precision. The first and most obvious answer is birds sleep. Of course they do. Every bird keeper has seen it, the slow closing of the eyes, the subtle ruffling of feathers, the shift into stillness. What is less obvious is what sleep actually does to a bird's body. When a bird enters sleep, its core body temperature drops, sometimes by several degrees Celsius. Its metabolic rate decreases significantly, conserving energy reserves that would otherwise be burned, simply staying warm. The Cornell Lab has documented this thermoregulatory sleep response across dozens of species, from canaries to corvids. It is not simply rest, it is a controlled physiological descent. But here is the detail that most people miss. A roosting bird does not simply close its eyes and wait for morning. Its feet lock, literally. A tendon mechanism called the digital flexor, a passive structure requiring no muscular effort, automatically cinches the toes around whatever branch or perch the bird has chosen. The bird cannot fall. Physics itself holds it there, through the night, on a wire above your kitchen or on a branch over a suburban street in winter. The second reason your bird behaves differently at night is more unexpected. It is not simply resting. In many species, it is navigating. The discovery that bird brains process magnetic field data during sleep-adjacent states was not made in a birdwatcher's backyard. It came from a 2014 study published in Nature Communications, led by researchers at the Max Planck Institute for Ornithology in Seewiesen, Germany. The team found that certain migratory songbirds exhibit heightened cryptochrome protein activity, embedded in the eye that are sensitive to Earth's magnetic field during the pre-dawn hours, even while the birds appear to be still. At 3 a.m. while you are asleep, a European robin perched in a hedge outside a German research station was, in a measurable biochemical sense, orienting itself. Not flying, not moving, orienting. Its visual system was processing magnetic information in the dark, calibrating something. The precise nature of which researchers are still working to understand was not a fringe result. It has since been supported by behavioral studies at Lund University in Sweden, which showed that migratory restlessness, the state birds enter before seasonal movement, is not random. It is directionally consistent within individual birds across multiple nights. Something is being calculated in the dark. The third reason, and the one that the darkness makes easiest to hide, is predation, not hypothetical predation. Real, recurring, catastrophic predation happening at a scale that daylight almost never reveals. A roosting bird in the wild is, in terms of detectability, about as visible as a mammal allows it to be. It is stationary, it is warm, it is exhaling. The barred owl, Strix varia, hunts almost exclusively by sound, and it can detect the auditory signature of a sleeping bird's breathing from distances that would seem implausible if they had not been measured. A single hunting owl in a suburban forest corridor takes birds in numbers that leave no trace, no feathers at the kill site, no witnesses. The eastern screech owl works differently. Smaller, faster. It exploits the gap between when most birds have roosted and before the deepest phase of the night has settled in, roughly 40 to 70 minutes after full dark. The strike is so fast, the perch so quickly vacated, that a bird roosting 3 feet away from the target will simply find itself alone at dawn, with no record of what happened. Domestic cats, this is the counterintuitive agent, are responsible for an estimated 1 to 4 billion bird deaths annually in the United States alone. According to a 2013 study published in Nature Communications by Loss, Will and Mara of the Smithsonian Conservation Biology Institute, The majority of those kills happen between dusk and dawn. The cat leaves, the bird does not return, no evidence, no explanation. What this means is that the full answer, why birds vanish so completely into the night, why your awareness of them simply ends at dusk, is not one thing. It is the convergence of three separate truths operating simultaneously. The bird is sleeping, physiologically transformed, its metabolism lowered and its grip locked. It is, in some species, passively processing spatial and magnetic information during the vulnerable hours before dawn. And it is navigating a nocturnal threat landscape so efficient at eliminating evidence that absence itself is the only record. You were right to notice that you never see what happens. Almost nothing survives to be seen. But here is what changes when you hold all of this together. It forces a deeper question, one that researchers have only recently begun to take seriously, and one whose answer is considerably stranger than anything contained in the three explanations above. For most of the 20th century, the assumption was clean and simple. Birds sleep, and sleep is unconscious. A resting bird was believed to be, neurologically speaking, mostly off. The lights were dim, the machine was idling, and complex awareness, social memory, emotional processing, anything resembling experience, was presumed to be absent. The research that began to dismantle this assumption emerged quietly, across multiple institutions, over roughly a decade. What it found was not what anyone was expecting. In 2016, a team led by Niels Rattenborg at the Max Planck Institute published findings in Nature Communications demonstrating that birds experience both slow-wave sleep and REM sleep, the same two-phase architecture found in mammals, but that they can engage in unihemispheric slow-wave sleep, a state in which one hemisphere of the brain sleeps while the other remains alert. In this state, a bird can keep one eye open and monitor its environment. The implications of this finding were not fully processed at first, but when combined with earlier work on sleep architecture in birds by Jerome Siegel at UCLA's Semel Institute for Neuroscience, a picture began to form that was genuinely unsettling. The bird on the perch, eye half open, one brain hemisphere resting while the other watches. This was not simple sleep. This was a form of distributed consciousness with no clean human equivalent. In 2022, researchers at the University of Buenos Aires published an analysis enzyme PLOS ONE showing that certain corvid species, crows, ravens, jackdaws, exhibit rapid eye movement during sleep that corresponds with increased neural firing in regions associated with memory consolidation. The birds appeared, by every measurable indicator, to be dreaming, not in a poetic sense, in a neurological one. What the evidence shows is this: a sleeping bird is not unconscious in the way we once assumed. Some portion of its brain may remain aware. Some portion may be consolidating the events of the day into long-term memory. Some portion, in certain species, may be experiencing something that the available language is not quite adequate to describe. The restraint that scientific honesty demands here is significant. Researchers have not proven that birds dream in the experiential sense. They have proven that the neural correlates of dreaming, the physical signatures, are present. It would be a mistake to claim more than that. It would also be a mistake to dismiss what that means. What remains genuinely unresolved, and this is the honest edge of the research, is whether unihemispheric sleep and REM phase neural activity in birds correspond to any form of subjective experience. The question of what it is like, if anything, to be a bird in REM sleep is not answered by the data. It may not be answerable with current tools. What researchers at the Max Planck Institute have been candid about is this: we know the hardware is running. We do not know what the software is doing. There is also a genuine open question about species variation. The neurological complexity documented in corvids does not appear to apply uniformly across all bird species. Whether a parakeet or a canary undergoes the same REM phase memory consolidation as a crow is something that published literature has not yet established. The field is not yet unified. So here is what is actually happening to your bird every night. The complete answer in two registers. The practical one: the moment the light drops, your bird descends into a thermoregulatory sleep state, physically locked to its perch, metabolically slower, and in the pre-dawn hours, potentially processing environmental or spatial information in ways its waking behavior does not reveal. That is the biological truth. And the stranger truth: somewhere in the night, in a state that looks like unconsciousness but is measurably not, your bird's brain is doing something. Consolidating, monitoring, possibly replaying. The animal you watch during the day is not absent at night. It is somewhere else, in a place that science is only beginning to map. You asked what happens to your birds at night. The answer is this: they go somewhere you cannot follow. They always have. Every night, for as long as birds have existed, the dark has held a version of them that the daylight never shows. Have you ever watched your bird fall asleep? Leave a comment with exactly what you saw, what species it was, where it roosted, what position it settled into, and whether it ever seemed to wake suddenly in the night without any obvious reason. I read every one of these, and the details you carry from your own experience are exactly the kind of data that builds towards something real,